Yo guys, we are back and today I will show you how you can set up your own gRPC stream to get the latest Pumpfun token creations lightning fast, just as you can see here on the site. I will go over how you can set it up, how you can actually extract the mints from the data that you get back, and also how you can get access to an actual gRPC stream. So if that sounds interesting, like the video, and also if you have questions, put them in the comments. I will do my best to answer them as quick as possible. But if you want these questions answered quicker, you can always consider joining our Discord. I will put the link in the description. We have a lot of members there. We talk about token snipers, token bots, also the gRPC setups. So if you have questions, jump into our Discord. People are there to help you out. Link will be in the description and I'll hope to see you there. Alright, so before we jump into the code, I want to show you which gRPC provider I use. And at the moment I use Solana Vibe Station. I think they are the fastest out there. They also have really good pricing, and I think they're just the best gRPC provider at the moment. You can read a bit more on their documentation about what gRPC streaming is, but the main takeaway is that it uses a library called Yellowstone Dragon's Mouth. It's open source, but it's well maintained. It's actually kind of a standard. But the key benefits is that it is really quick because it uses the network resources in a more efficient way, and it also has streaming capabilities, which means unlike REST, you don't do a request and you get an answer. It opens actually a continuous stream of data that you can tap into. So you can read more about gRPC, what it is, on their documentation. But this is the provider that I use. It's called Solana Vibe Station. I will also show you in the video how you can subscribe to one of these gRPC streams. It's really easy via the Discord, and you can also pay with crypto. So we will look at that during the video. But again, I just wanted to mention that I use Solana Vibe Station. I think it's the fastest out there. And with that said, let's jump into the actual code base. Alright, so this is my IDE. I have it open here. And as always, in the package.json file, I have a start command, which is called def. And def in turn starts the index.ts file. So the stream starts from the index.ts file. So let's have a look at this file here first. And as you can see, it has a lot of things that are going on, but I will go over all of them with you so you know exactly what is going on and how you can set up this stream yourself. So first thing that we do is, of course, importing our gRPC endpoint. And the gRPC endpoint for me is stored in the process env svs gRPC HTTP variable. And these come from my .env file over here. And for this video, I only have one variable in here, which is the svs gRPC endpoint. And as I said earlier, this will be the same for everyone. The only thing that you will need to do is subscribe to SVS to get your IP whitelisted so that you can talk to this endpoint. And I will show you later in the video how you can do that. But for now, you can just know that we use this endpoint to actually talk to the gRPC service. And that is what we import over here. And we have a fallback address. In case nothing is found here, then we will use the same URL as well. Now, the Pumpfun programs and the Pumpfun transaction discriminator, they are actually stored in the config file. And we can also have a look at that. They are stored here under gRPC programs. I have Pumpfun noted here. And as you can see, this is the program that we will listen for. And the discriminator is the unique value that we will look for within this payload that will be returned to us to actually identify data that has to do with Pumpfun creations. That's what I can say about that now. You may have seen that it can also be done by using program logs and looking into the logs for certain instructions. It's actually almost the same. Here we were just using buffers instead of actual strings, and I would say using TypeScript, using string actions would probably be preferable, and we can go over that in short also during this video, as TypeScript is highly optimized for anything that has to do with strings, for example, include actions and all these kind of things. But first we will look at how we can use the actual discriminator in buffer form that are mentioned in the IDL programs from pump.fun. But again, this information is mentioned here in the config, and then I import it here on top of the file so that we can use the program and also the discriminator further on in our application. Commitment is the commitment level that we set for the gRPC. This comes with the package that I mentioned earlier, the Yellowstone gRPC from Triton. It's well maintained, really good package, and as I said, it's kind of a standard, and here you can just set commitment level to confirmed so that we can use this commitment level in our gRPC stream. So these are the variables that I declare here on top, and then if you go through this file, you will see that there are a few functions declared, but eventually we will start main here, and main is actually declared here on top. So once we start main, the function main or the function called main will start. And the first thing that we will do is create a client stream. And again, client comes with the package Yellowstone gRPC. And here we will initiate a new client connection using our gRPC connection string or URL. We will provide no token as it is not needed for SVS. But we just create a new client instance and we call it gclient. Based on the gclient instance, we will trigger the subscribe method, and that will create a actual G stream for us, or a client stream that we then later can use to send a subscription to. We will also create a request, and like we do, for example, with WebSockets, to use gRPC, we also need to subscribe to the gRPC to get certain data back, and that is what we do with this create gRPC subscribe request. So if you click on that, that's also specified here on top, and we can look at what that does. So this function will just return to us an object that is actually required to send to the gRPC stream in order to subscribe. And what do we mention here? We mention pump.fun, and that will be just a unique identifier that we use to see when the data comes back, it will have the tag pump.fun. That's why we wrap it within this object. And then we have the accounts that we want to include, and that are our pump.fun programs. And as you can see, this is an array. If I click on the program ID here, this is an array of programs, and that is what we actually provide here in the transactions that we want to look for pump.fun account to includes these pump.fun programs. So this will just return this object back to us, and that is in the form of a subscribe request. And subscribe request also comes with the package Yellowstone gRPC. So this is what we will have returned here, and we store it in the G request variable. And what we will do then is actually subscribe to the stream, and we will send a subscribe request. And the stream will then emit events to us based on the subscription request. And that's what we do with the send gRPC subscribe request. And what we provide is the G stream that we created here, and also the G request. So we will subscribe on this stream with this request. And we can also look at this function here. It is specified here on top, and what this does is actually writing to that stream that we provide here the request, and we just wrap this into a promise. And what we do here is actually promisify this request. And why do we do that? So that we can trigger this send request function here in this way. What we could also have done, and I commented here, is just write gstream write request, just the same thing as we did in this function here, but the way of doing it this way makes it more interesting, because if everything goes well, it will resolve, and if there is an error, it will reject. And then we can just write it in this way and wrap it into a try-catch statement, and then we will always know that we have a valid request that has been sent that will resolve, and if something goes wrong, then it will return an error to us. And this is called promisifying a function, or that's what we are referring to if we do it this way. But that is the way that it is set up for now, and this is the function that will take care of that, the send gRPC subscribe request. But what you can think of is that it will just write a request to the stream that we provide here. And again, we provide the stream here, and this is the request that we write it to. So then we will just wait, and if everything goes right, no errors will be thrown, and we can move on. And then we also log out like, hey, the subscription request has been sent successfully, and we should be subscribed to this gRPC stream. Now, the next thing that we need to do is create listeners. And remember, when we have a WebSocket connection, we also have to do that. Once the WebSocket connection is opened, then we will create listeners like open, message, error, all these kind of things. We need to do the same for our gRPC connection. So in that sense, it's quite similar to a WebSocket connection. And this logic, again, I did the same approach as I did here with the send gRPC subscribe request. I also promisified this by putting it into this create gRPC stream listeners, and that's also declared here on top, so we can have a look at that. And as you can see, this will look quite familiar to you, but what we do here is take this stream and we create event listeners, you can say. So when we receive data, then we will do this. If our stream receives an error, then we will do this. If our stream ends, then we will do this. And if our stream closes, then we will do this. But the main thing that we will look for is when we receive data. And that data we will parse into the handle gRPC data function. And that function is also declared here in our script. And we will have a look at that in a minute. But to go back to the main function, this is where we handle the stream events that I just showed you, like data, error, end, and close. And this function will then process for us the incoming data and also handle the errors efficiently and send the data that comes in to our function called handle gRPC data. All right, so now that we know that we have set up our actual gRPC stream and that we handle the data properly, and once we receive the data, that it is sent to our handle gRPC data function, it is time to look at this function actually and see what we can do with the data once we receive it. So the function is declared here and called handle gRPC data. So let's have a look at that. And the first thing that we want to do is validate the data that we received, that it is actually valid. And for that, we have a function called isValidGRPCDataUpdate. We can also look at that, and this function is specified in a separate file called utils.ds. And if you open this, then you will see that it just takes the data that we parsed into this function and will check if it actually matches the object that we are looking for. So I have an example request or an example data that is being returned by the gRPC over here to make the point a bit more clear. So what does this function do? The data that has been received will be parsed in this function. And then for that data, we will check if transaction is included. And if you look back at the example data here, transaction is there. So it contains a transaction. If you then go back, the next thing that we want to see is the data.transaction, if it's an actual object. And if we look at data, transaction, is this an object? Yes, it looks like an object to me. So that's also fine. The next thing that we will check is data.transaction. Is it null? And if we go back to this, it seems that it is not null because the object is there and it contains some data. So then we will check if the value slot and transaction is there in transaction. And again, we can look at the example and we see that slot is here and that transaction is also present within transaction. And the next thing and the last thing that we want to check is if the data.filters actually includes Pumpfun. And remember, Pumpfun is the thing that we note down, let's say, once we created the request. And if we go back to our index file, I think it's under the create subscribe request. As you can see here, we say Pumpfun, and that is what it will return to us then here within the payload filters Pumpfun. And that is what we actually also look for here, like, hey, does filters include Pumpfun? And if that is all true, then this function will return true. And if it's false, it will return false. And that is what we want out of this check here. If it is not true in this case, then we will return and we will not continue handling this data. All right, so if this returns true, then we know that we received valid data back from the gRPC stream that we can use to look further into and see if it has to do with liquidity pool creations, or in this case, actually new pump token creations. So if it is true, then we return, and then we will extract some data from this data that was returned to us. And that's what we actually do here. And as you can see, the first thing that we want is the transaction, and that is stored under data transaction, and we can go back to the example, data transaction, and that is what we will take out here, and then store it into the variable transaction. The next thing that we want to take out is message, and that is stored within transaction message. And if you look back at this, it's transaction message, and that is the data here that we take out and store in the message variable. And the next thing that we take is instructions, and that is stored in message instructions. And if you look at that, then it's message and then the instructions over here. So that is what we then take and store into this variable here, instructions. And then we just check if any of these variables that we stored this information in is empty or null, because if that is the case, then we also return, because then we don't want to handle that data. But if it's correct, then we can move on, and then we know that we have valid data that we could extract from this data object that was returned to us. So now that we know that we have these variables set up and that the data in it actually is proper, we can start by looking into these variables separately. And the first one that we will check is the instructions. And what we will try to do there is find certain creation data. And that also will return true or false. And if it is false, we will not continue. And what we will do is go through these instructions and try to find the first one within this instruction data. And again, instructions, it looks like this. It's in the message instructions. So within this object, we will look for certain instructions. And to do that, we have a function called matches gRPC creation data, and that is what we will feed these instructions in one by one, and we will look for a certain instruction, and that logic is handled within this function here. And if we click on it, it's also declared here on top. We can have a look at that. So what we put in here is the actual instructions, and within instructions, again, what we will look for is data. So as you can see, all these instructions here, they have a value called data, and that is what we will look for, or we need to make sure that that is present. And that is the first thing that we check here, is the instructions.data there. And if it's there, we also need to make sure, because we say here n, that this logic is also returning true. And what we do here is looking at the pump.fun transaction discriminator. Remember that we declared here on top in the beginning, and it's actually referring to this buffer here on top that we specified to match certain instructions within our data to make sure we are looking at the right instructions that have to do with the creation of a new token. And within this discriminator instructions or transaction discriminator, we will look for a discriminator. Again, if you go back here, discriminator, that is what we are looking for. And then we will try to match it against the data that has been inserted, or the instructions data field. Remember here, if you look at it, the data field holds a certain buffer, because it says here data type buffer, and we will try to match it against the first 8 digits, because these are often unique, and that's what we mean with slice. So we will look at these instructions over here, and we will go through all of them, and then we will look at the data, and the data we will try to match or see if it equals to the actual instructions over here in our discriminator. And that's what we do here. So for this discriminator, we will look and take this discriminator and see if it equals to any of the discriminator within the instructions that have been provided. And if this returns true, and it also contains the actual data, then it will return true to us. And true means just here that it found an instruction that is actually valid. And in this case, the instruction that we are looking at has to do with the creation of a Pumpfun token. And this information, of course, can be found in the ideal program instructions, but we know that this buffer has to do with the creation of a Pumpfun token. So, if we know that, then we return true, because let's say we are looking at data that has to do with something else, like an object like this that has been returned to us, because the first check, of course, was did we return or receive a valid object? Could we extract these instructions or values? And then we check if it actually matches the instructions that we are looking for. But often we can also get data that is valid, but has nothing to do with the creation of a new token. It can be a buy instruction, a sell instruction, it can be any kind of instruction. And that is why we have to look within these data that's been returned. Does it contain the instruction that has to do with the creation of a token? And that is what we do with this function here that we just showed. And if this does not return true, then we know that this is not an instruction related to creation of a token, and we will return. We will not move on. But if it is true, then we know that we are looking at data that has instructions to create a token, and now we are interested in extracting the actual mint, and that is what we will do next. Alright, so now the fun part will start. So we know that we have a data returned to us that holds a create token instruction, and now we want to get the mint out of it. And the next step that we will do is optional, but it's because I want to output this into the console once we find a mint, and that is finding the signature for this transaction. And to do that, I have a function called convert signature, because the signature is also part of the data. And as you can see here, transaction signature holds our signature. And if you click on transaction, we know that it is data, transaction, transaction. And if you go look at the example again, data, transaction, transaction, and here we have the signature. But the signature is also in buffer format and not like in the base format as we are used to see them. So we will need to convert this into the right format. And that's what we will do with this function here, convert signature. And if you click on it, then it also opens in the utils.ts folder. And then you can just expand on it. And here you will see that it will return a base 58 encoded value based on the buffer from this signature. And what that will do is just return to us the signature in the format that we are used to see it, which is base 58. And I also have a test here to showcase you how that works, and I can show you really quick what it does. So this is the exact same function. It takes the signature object from the buffer, the same as in the example here. Remember the signature object, but here we just create one, and then we use that function to turn it into a base 58 encoded signature. And then we call that function the same way as we do in our main script, and we log it out. And to run this, you just have to open a terminal, open the terminal and type in npm run convert. And then you will see that it will trigger this functionality here, and you will see that it turns this buffered signature into a base 58 signature that we are used to see, and that you can also enter into, for example, SolScan, and then you will see that exact transaction. I can show you what I mean. If we open here, for example, let's say SolScan, we enter this transaction in here. This should refer to a create instruction for a token on Pumpfun. And it actually does. It's from 2 days ago, where we created the token X. So that's what this functionality does for us within this script. So we can just close this here. But this will just return to us the actual signature in this right format that we can later on log out in our console. All right, so now we have the signature of the actual create instruction. So that's a good start. But we also want the actual mint, so we can output the mint straight away once we found the token. So To do that, we have a function called lock tokens, and that function we just provide with the signature that we created here earlier, and also the message. And the message is what we had here on top, where we took the data from transaction message. So these two we will parse into the function called lock tokens, and lock tokens is actually specified here on the bottom, and that will eventually output the tokens for us in the console. So we can have a look at what that does. So the first thing that we will do is again see if the instructions match the actual instructions for creating a token. And we did this earlier, as you can see here in the handle GRPC data. We checked if we were looking at a actual creation instruction, but now we will do the same, and once we find something, we will store that instruction into a variable that we can actually use later on to extract the mint. So what we do here is find that instruction within the instructions, and as I said earlier here, if you go back to transaction, it is under transaction, message, and then instructions. These instructions we looked through earlier, and we saw like, hey, there is one instruction that matches the creation of a token. But what we will do now is go through these instructions and we will try to find it. And if we find it, this instruction, for example, then we will store that instruction into a constant called matching instruction. So then we have that instruction that we need to work with. And here I commented out how that looks. So as you can see here, for example, all these instructions, that is where we will try to find the one that we are looking for and then store it in the constant, and that is how it will look. And this is an example. So the next thing that we will do is go and look at the account keys. And the account keys, they come via the message that was provided here, and then account keys. And again, we can look at the example. So message, and then we have account keys. And these are all the keys and mints that have to do with this transaction. And of course, they are in buffer format, but they are interesting to us. So that's why we also store them into this account keys constant. And as I showed earlier, this is how it looks. So now we have the actual instruction in buffer format, and we have all the account keys also in buffer format. And the next thing that we will do is look at this matching instruction that we extracted here earlier that looks like this. And what we will do is look at accounts. Again, here on top, accounts, and this is actually, as it says here, matching instruction accounts is a uint8 array buffer, and that's what we will use to look at the first buffer number, you can say here, and that is in this case 01, and that is what we will put into the account index. And then we know, based on that account index that we stored here, we can look back at our account keys, which look like this. Take the first element, because that's the index that we extracted, and that should be the mint from the token that we are looking at. And what we will do then is, taking this mint as it is a buffer, turn it into a public key object and extract the base 58 format of that. And that will be the key or the CA that you are used to see when you look at a token, and that, yeah, you can use to actually buy the token or actually check out the token. So that's the logic that we use to extract the information or the CA from the instructions from our data. All right, so now that we have that data, we can also output it in our console, and that is what we do here by writing console log, and then just a signature that we extracted earlier, the mint, and we also create these links so that we can click on it and see the actual transaction and the coin on pump.fun. And I also want to show you, like I showed earlier in the config, we can also look at the logs as the discriminator. And what I mean with that is, you look at the example. Under meta, instead of signature, you have like under transactions, you also have a thing called meta, and under meta, you have a value called log messages. And these log messages, they are actually the log messages that you can see here at the mint or the transaction that we were looking at earlier. If you scroll all the way down, these log messages, they are the same as the ones that are presented to us here. And here we could also look for certain instructions, for example, program log instruction create. And if you go back to config, that is what we are looking for, or create pool, it should be create in this case. So in this case, we could look in these instructions if there is the instruction that we are looking for. And if that is the case, then we could look at the post token balance accounts and look at what mint we actually can work with. And here you can see that also the mint is present of that token. So if we look at that mint, and we know that this was X, so we can also put that in here. And then if you see at that mint, this is the token X. So this is also a way of extracting the data or the mint from the data presented to us via gRPC. But in this video, we used the actual buffer instead of the logs. But as I said earlier, I think it's more beneficial to actually look at the logs, as TypeScript is highly, you could say, performant if it has to do with things like strings, interactions, and all this kind of things. So looking at the logs is also a really good alternative for finding instructions and then taking the mints from the post token balances or pre-token balances. So I just wanted to throw that out there so you know that it is possible to do it that way as well. But for this video, we just chose to use at the buffer index, so you also know how to do that, because looking at the logs should be an easier way of finding these tokens. So that's the logic that we use to run this bot. And if we want to run it again, we just type npm run dev, and that will start the bot and start looking for the tokens on Pump. And as you can see here, it outputs. So if we would click on this, for example, open it, that would open Pumpfun for us. And then we can see that this token is just created. It's not really old. It's called Kids. So that is a newly created token. And that's how we can see that it works. So to get the gRPC connection subscription, what you can do is go to the Solana Vibe Station, and I will also include this into the description. And under, I think it is, let me have a look, purchase services, what you can do is go to this channel here, and then you can purchase a service. And in this case, we are looking at the gRPC service. And after the gRPC service is bought, you can go to update connection, and here you can add your IP to be whitelisted for the gRPC connection. And you can also look at connection info, where they have more information on what URL you can use. But as I said, the URL should be the same once you bought a subscription and whitelisted your IP. And as I said, you can pay with crypto, so it's a really easy service. They are really fast, and again, Solana Vibe Station, it's recommended. I use it also for all my tools if I use gRPC. So check it out. The link will be in the description, and if you have questions about that as well, you can join our server and ask about it, or join the Solana Vibe Station server, and they will also be happy to help you. So that's how we set up the gRPC stream to fetch new tokens on pump.fun. I hope you think it was interesting. If you do, like the video, and again, I hope to see you in Discord, and I hope to see you in the next one.